Hi, welcome back to my channel. My name is Gina. In this video, we are going to talk about the determinant function of a matrix. For square matrices, we can find its determinant. And determinant is a function. A function is we put in some input, and the function does some work, and it will give you an output. So the input here is the square matrix. And the output of the determinant function is a real number. For example, if we let A be a square matrix of n by n. If I throw this matrix into the determinant function, we can denote that as determinant of A, or we can abbreviate that as absolute of A. Then the output of this function will give us a number, a real number. To find the determinant of a matrix, we need these two definitions. The first one is the minor matrix. And we get this minor matrix by deleting the rows and the column of the entry. For example, I have an entry in the second row and first column. Then the minor matrix of this entry would be the entries of matrix A after I delete the second row and the first column. The second thing we need is the cofactor of an entry. And we define the cofactor of an entry as -1 to the power of the ith row plus the jth column times the determinant of its minor matrix, Aij. And to find the determinant of a matrix, we are going to use cofactor expansion. Here's an example. For n greater than or equals to 2, we can find determinant of the matrix A as follows. We take the first entry in the first row and first column times the cofactor in the first row and first column, then plus the second entry in the first row, so A12 times cofactor of the entry. And we do the same until the last entry of the row. So A1n times C1n. And the theorem says we can find the determinant of a matrix by cofactor expansion along any row or any column. The example I gave, I was using cofactor expansion along the first row, but we can actually find the determinant of a matrix along any row or any column. Let's look at this example. Let's find the determinant of the matrix along the first row and the first column, and let's check whether we'll get to the same results. Let's start with along the first row, which is A11 times C11 plus A12, the second entry in the first row, times its cofactor, then plus A13 times C13. So this equals A11 is 0, so the first term will be 0. Then plus A12 is 1, and C12, the cofactor of this entry, it will be -1 to the power of 1 plus 2 times the determinant of the minor matrix after we delete the first row and the second column. So the other four entries we have here are 3, 5, 6, and 8. And the last term plus A13, which is 2, and C13, the cofactor, is -1 to the power of 1 plus 3 times the determinant of the minor matrix by deleting the first row and the third column. So the four entries we have are 3, 4, 6, and 7. And this equals, in the exponent, 1 plus 2 is an odd number, so we'll have a negative sign. And we know how to determine the determinant of a 2 by 2 matrix, which is the product of the opposite sides, so 3 times 8, that's 24, minus the product of the other opposite entries, that is 3. Then the last term, in the exponent we have 1 plus 3, that is an even number, so the sign is positive. So plus 2 times the 2 by 2 determinant. 3 times 7 is 21, and minus 6 times 4, 24. We get negative of negative 6 plus 2 times negative 3. So 6 minus 6, that is 0. Now let's compute the same determinant along column 1. So it will be A11 times C11 plus the second entry of the first column, that is A21 times C21 plus the last entry along the first column, A31 times C31, which equals A11 is 0, so the first term is still 0, then plus A21 is 3, and C21 is negative 1 to the power of 2 plus 1 times the determinant of the minor matrix after we delete the second row and the first column. And the 4 entries that are left are 1, 2, 7, and 8. Then plus A31, which is 6, and C31 is negative 1 to the power of 3 plus 1, then times the determinant of the minor matrix after we delete the third row and the first column. So determinant of 1, 2, 4, and 5. And this equals negative 3 times the determinant, 8 minus 14. Then plus 6 times the determinant, 5 minus 8, which equals negative 3 times negative 6 plus 6 times negative 3. So we have 18 minus 18, and we get to the same answer. The determinant of this matrix is 0. And that is the end of the lecture. If you are interested in the complete course of my linear algebra course, I'll put the link down below. If you like my videos, please like and subscribe, and I'll see you in the next video.